Hello people and welcome back to another video. In this video, we'll be discussing the second important tool that is at our disposal when it comes to statistical inferencing. Now, as you know, we have already discussed statistical inferencing in a previous session where we discussed that statistical inferencing is the process of extrapolating the conclusions that is derived from a sample in order to predict a population parameter. The first tool at disposal, which was confidence interval, we have discussed that in our previous section. You guys can go and check that out. In this particular session, we'll be discussing on the second tool that is at our disposal, which is hypothesis testing. Now, in hypothesis testing, we follow a set of procedures. Let me go over them one by one. First of all, we set up a null hypothesis or an initial condition. Usually, this initial condition is a condition of no change. Let me explain this through an example. So, for if I am eating a lot of chocolate and suppose we want to see the after effects of eating exorbitantly huge number of chocolates, and I say that the initial condition is that eating a lot of chocolate does not have any significant impact on my weight. This is the initial condition or the initial statement. Now, what we do in hypothesis testing is we follow something called as a test of significance. More on that in later sessions, but giving you a brief idea, we follow test of significance in order to conclude or surmise evidence against the null hypothesis. So our goal in hypothesis testing is to disapprove the null hypothesis or go against the null hypothesis. So here in this case, we want to accumulate and gather as much evidence as possible against my null hypothesis that eating large amounts of chocolate does not have any significant impact on my weight. So we want to collect evidence to prove that eating a lot of chocolates will actually have a significant impact on my weight. So there are two key terminologies that we need to understand. As I said, there is an initial condition and we need to go against the initial condition and find evidence against this initial condition. This initial condition is represented by HO, or it is also called the null hypothesis. This is also the condition of no change because most of the time, null hypothesis indicates that there is no after effects or no change after a certain event has occurred. The alternative or the opposite to the null hypothesis is called the alternate hypothesis or HA. It's represented by HA. It is called the alternate hypothesis. Hey, so we have understood the concept of null hypothesis. We've understood the concept of alternate hypothesis. Now, alternate hypothesis can be one-sided or it can be two-sided. Now, let me make you all understand this concept of one-sided and two-sided using an example. So, right at the onset, I mentioned that in statistical inferencing, we are concerned in predicting the population parameter from the sample that we have. Okay, so let us take the first example. The example states that a gym is interested in whether or not a 6-week weight loss training program they launched has been successful in helping their clients lose weight. To assess this, they took a sample of 30 participants. State the null and alternate hypotheses. So, first things first, as I mentioned to you all, the null hypothesis deals with the condition of no change. So let us suppose that we have certain amount of people, we have 30 participants here. They went through this program, and our first null hypothesis condition, if I had to mention, with respect to what we are calculating weight loss. So assess the efficiency or the efficacy of the weight loss program. I'll take the mean of weights of each participant, and after the weight loss, I will take the mean of all the participants once again. If this program is effective, then there has to be a significant decrease in the mean of weights taken initially versus the mean of weights taken after they have gone through the program. So with that in mind, the null hypothesis in this case will be the population parameter mu of the weights of participants is equal to 0, or the change in weight, the change in mean weight of the participants before and after this training program is 0. This is going to be my null hypothesis. If the change in weights is 0, it means that there is no difference in the weights, and there is no change that really happened with respect to this training program. Now, my alternate hypothesis that I'm concerned with is the efficacy of this training program. So ideally, we want that the difference between the final mean weight and the initial mean weight should be negative, because we want a decrease in the weights. So the alternate in this case will be mean is less than 0. This is how we proceed when it comes to hypothesis testing. We have a null hypothesis, which is the condition of no change, and we have the alternative hypothesis, which can be either one-sided or two-sided, depending on the context. This is an example of one-sided, because here we are only concerned with one out of the two possibilities. The other possibility could have been an increase in weight of the participants, but that itself would have told us that the program is ineffective. We are concerned with finding evidence that proves that the program is actually effective, which is why we'll go for the first condition, which is the sample mean is less than 0. Now we look at one more example, and this example will help you understand the difference between one-sided and two-sided. We have already seen a condition of one-sided. Now, this is an example that elucidates how a two-sided alternative hypothesis problem is crafted. Now, the example reads, county officials are interested in measuring a particular chemical in water sources in the county. High levels of this chemical are harmful, as are low levels. Either indicate a need for intervention. Normal levels of this chemical are 15 parts per million. County officials will start an intervention program if the chemical mean level in the water source is different than 15 ppm. So what is our initial condition? That the chemical concentration in the water source is at a normal state or an equilibrium state. That equilibrium state is given by 15 parts per million or 15 ppm, which is the equilibrium state. The non-equilibrium state can be either greater than 15 ppm or less than 15 ppm, because both higher levels and lower levels of chemicals indicates a sign of harmfulness in the water bodies. So for this case, if I have to write the hypothesis test for one-sided and two-sided, sorry, for null and alternate hypothesis, this is actually a two-sided hypothesis test. So here, my null hypothesis will be the average concentration is 15 parts per million. All right. and my alternate hypothesis will be my chemical concentration or mean chemical concentration is not equal to 15 parts per million. So I hope you understood the difference between one-sided and two-sided. In one-sided, we are only concerned in finding evidence for one of the two possibilities of alternate hypothesis. And in case of a two-sided alternate hypothesis, we are concerned in finding evidence for both the scenarios. Here we need to find evidence for mu greater than 15 ppm and also for mu less than 15 ppm, as both lower levels and higher levels of chemicals indicate a sign of harmfulness in the water bodies. So I hope through this session you've understood what is the basic idea of hypothesis testing, some of the key terminologies that you need to keep in mind, and how do we surmise whether for a given problem we need to go down the route of one-sided alternate hypothesis or a two-sided alternate hypothesis. We'll continue hypothesis testing and we'll get into the finer nitty-gritties of hypothesis testing in our upcoming sessions. But we'll end this session here. I would thank all of you all for watching this session, and I'll see all of you all in the next session. Thank you.